But in order to talk about intermolecular forces, the forces between molecules, I need to review the concept of polar and nonpolar molecules. So to get started, the atom that is more electronegative in a covalent bond, it is going to hog the electrons, and as a result, we say that it has a partially negative charge because it has a higher electron density around it. So it's partially negative, not completely negative because it hasn't stolen the electrons, but it's hogging the electrons towards it because it has a greater attractive force for those electrons. Now, if you have a less electronegative atom, the atom that's less electronegative, it's going to have a partially positive charge. And so there's going to be a separation of charges, a partial positive and a partial negative. And that separation of charges is called the dipole, and we represent it as an arrow. So as you can see here, fluorine is more electronegative than hydrogen is. So fluorine has a partial negative charge while hydrogen has a partial positive charge. So we represent that dipole with an arrow, as you can see on the right-hand side. Now, in determining if a molecule is polar or nonpolar, if the dipoles do not cancel out, then the molecule itself is going to be polar. So hydrogen and fluorine, that hydrofluoric acid right there, is going to be polar because, as you can see, that arrow, that dipole, is not canceled out. If the dipoles do cancel out, then the molecule is going to be nonpolar. So let's look at an example in which the dipoles do cancel out. Let's look at carbon dioxide. Now, if you draw the Lewis structure for carbon dioxide, it's going to have two double bonds, and therefore it is going to be a linear structure. Now, because oxygen is more electronegative, both oxygens there are going to have a partial negative charge, and so the arrows are going to point towards the more electronegative atoms, so they're going to be pointing towards oxygen. Now, if you look at that, since you have an arrow going to the left and an arrow going to the right, those dipoles actually cancel each other out, and as a result, the molecule itself is going to be nonpolar. So being able to identify molecules as polar or nonpolar is key when we're determining the type of intermolecular forces. And there are 4 different types of intermolecular forces that we're going to very quickly look at. The first one is London dispersion forces, also just called dispersion forces. Now, London dispersion forces exist in every single molecule or atom that exists on Earth. There is always a slight attraction between atoms or molecules, even if we decide to ignore them like we did with our gas laws. So how exactly is that attractive force created? Well, if you look at this example, this is helium. If you have atom A and atom B, the electrons, which are shown on the top left and all of the top drawings right there, those electrons can be anywhere at any one instance. So if you look at the center diagrams, the one on the bottom, notice that the electrons happen to be lining up on the left-hand side of atom B. And since they are lining up on the left-hand side of atom B, because they can honestly be wherever, but they just happen to line up there, then the right-hand side of atom B is going to be partially positively charged. Well, since it's partially positively charged, that's going to have an effect on atom A, as you can see in the C diagrams. The partial negative is going to repel the electrons in atom A, causing the left-hand side of atom A also to be partially negatively charged, while the right-hand side of atom A will be partially positively charged. And so that separation of charges, even though it's a slight difference in charges, that's going to cause an attraction. That attraction is called London dispersion forces, and so it exists in every single type of molecule, in every single type of atom. So while I'm going to be talking about 3 more types of intermolecular forces, all of these also have London dispersion forces. Now, London dispersion forces, when we're trying to list out all of the different types of intermolecular forces that molecules or atoms can have, if you have a nonpolar molecule, the only intermolecular force it will have is London dispersion forces. Now, the other ones, or the other types of intermolecular forces I'm going to talk about, happen to be for polar molecules. The next type of intermolecular force is dipole-dipole forces. Now, dipole-dipole forces only occur between polar molecules. And that's because those polar molecules have a permanent dipole. And so dipole-dipole forces are those attractions between dipoles, the partial positive and the partial negative, that we saw in London dispersion forces, but it's permanent. And so as a result, it causes molecules to be even more attracted to one another. So molecules that are polar, they will have London dispersion forces, but dipole-dipole forces as well, which puts them over the edge, which means that they have an even stronger attraction between one another than nonpolar molecules. The third type of intermolecular force, which is hydrogen bonding. So if you look at this right here, in order to have hydrogen bonding, you need a hydrogen that is bound to either an oxygen, a nitrogen, or a fluorine, as you can see here, and then it's going to be attracted to another oxygen, fluorine, or nitrogen. And the reason why hydrogen bonding is so much stronger than London dispersion forces and dipole-dipole forces is because there is a great difference in electronegativity between oxygen and hydrogen. And so as a result, hydrogen there is going to be very partially positively charged, and the oxygen, fluorine, and nitrogen are going to be very partially negatively charged. And so that attraction is going to be even greater than it was in dipole-dipole because of the great difference in polarity. So that's the third type of intermolecular force. Remember, for hydrogen bonding, you need fluorine, oxygen, or nitrogen. It is fun. Hydrogen bonding is fun, but those hydrogens need to be bound to an oxygen, fluorine, or nitrogen as well. The fourth type of intermolecular force is ion-dipole forces, and these result from the attractive forces between a polar molecule, so for example water as you can see, and then ions. So as you can see with the chloride ion, it is attracted to the partially positively charged section of water, and for sodium, it is attracted to the partially negatively charged section of water. And so these are extremely strong because these attractive forces are extremely strong because chlorine and sodium have complete charges instead of just being partially negatively or partially positively charged. And so these ion dipole forces exist whenever you dissolve an ionic compound in water.